I'm back. So here we go. Chapter 7, we're going to go to the really fast boat. You need to pay attention. This is chapter 7. I'm going to go buzzing through it. I better start. All right, here we go. Chapter 7, section 7.1. The whole thing. I want you to check out the examples. I'm coming from the examples on page 463 to 464. That's actually the review test from that chapter. So here we go. 7.1. You're asked to simplify. Well, you follow the rules for exponents. What do? You end up with a to the 2/3 minus 1/4. Remember, those are the rules of exponents. Times b to the 3rd minus 1/3. So what does that come out to? Well, you got to change this up a little bit. So you end up with a to the 8/12 minus 3/12 and b to the 9/3 minus 1/3. So what does that come out to? A to the 5/12 times b to the 8/3 power. Using the rules of exponents. 2/3 minus 1/4, 3 minus 1/3. Section 7.2. I told you we're going fast. You got to pay attention. 7.2, they're asking you to simplify. How can you simplify when you got a rational number and a regular number, although it's exponential, but they don't have the same denominator? This is a denominator of, wow, magic, of 1. This is a denominator of x to the 1/4. So what do? We need to get this in the same denominator as that. So what I'm going to do is I'm going to multiply this, and I'm going to put it over on this side, by x to the 1/4 over x to the 1/4. Ta-da! So when I do this, I end up with x to the 4/4 plus 5 over x to the 1/4. What is x to the 4/4 power? Same as x to the 1st plus 5 over x to the 1/4. And that's it. 7.2, simplifying. Let's see if there's any more problems to go along with this. 7.2. Nope. Here we go. We're jumped to 7.3. Remember radical numbers? Yes? Ah! Scared myself. What we want to do is we want to be able to write radical numbers in simplified radical form. So here's some examples, and we'll call this easy. Because what you do is you factor the radicand. So we end up with the square root of 25 times 2. Why do I factor it that way rather than 5 times 10? 25 is a perfect square. The rules of radicals tells me I can also write this as the square root of 25 times the square root of 2. And as you know, the square root of 25 is plus or minus 5. And the radical 2 stays. That's easy. This is hard, but not too hard, because what we're going to do is we're going to factor this. This is the square root, so we're going to factor it into the square root of 9 times 2x squared. And if you want to, you can also do what we just did a second ago. We can rewrite it as the square root of 9 times the square root of 2 times the square root of x squared. What is the result? Plus or minus 3x radical 2. Oh wait, it gets harder. We're going to try this one now. Last one in this section, harder. We've got an index of 4, index or root of 4. That means what we want to do is we want to have exponents that match the index. So I'm going to rewrite this as 2 to the 4th Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 more is 32. So we need another 2, don't we? A to the 4th stays the same. B to the 5th, we're going to split it up into B to the 4th times B. C to the 6th, C to the 4th times C squared. Notice that we have the exponents here matching the index. That means that the base, remember this is the base, this is the exponent, that's the index. If the index matches the exponent, then the base comes out. 2, A comes out, a B comes out, and a C comes out. And that leaves a 2BC squared. That's harder. We got that? Okay, I'm going to actually stop it there and upload it, and then we'll do the other sections on a second one after this. Yes, that's what I'm going to do. See you in a moment.